Recording?
Yeah, we can edit the front bit out. So.
Welcome to another one of these recordings where we'll try and do a bit more practically, in particular how to set up a participant to kind of get them going to put the EEG cap on, and trying to demonstrate a few of these details. We've got various set up with a couple of cameras, so we'll see how we get on, and my assistant John is doing some editing.
Hello.
Okay, right. Sorry. Here we have our lovely participant, Mario, who's just come in to take part in our experiment. And again, social distancing means we'll have to use Mario and not a live participant in this case. The participant comes in, and the first thing we tend to do, obviously there's some consent forms and some instructions to be signed and so on first. But the first thing is welcome to the lab, and welcome to a EEG study. First thing we want to do is we want to measure the head. And the reason we want to measure the head is just to figure out what size cap the participant will wear. So there's a few different sizes. I'll show you in a bit. They're quite stretchy, so kind of a rough measurement. And you basically just take a measure at kind of like the biggest size around their head like this. And if you look here, this participant Mario is about 55.5 centimeters circumference, about 56. So that's a fairly small head, 56. I think the average is about 58. Anyway, so we get the appropriate cap. In this case, we got this one here. And then the first thing you do is basically just put the cap on. And hopefully Mario's head won't split open. There we go. Comfortable? Yep, good. Here we go. Okay, it's basically, so in these kind of experiments of this cap, it's essentially just like a swim cap, which has got loads of lift and hose where you can put electrodes in. Once you got the cap on, it needs to be in the right place. And as we talked about earlier in a previous recording, we have this kind of 10-20 system which tells you where the electrodes are. Now these aren't numbered, these aren't labeled with the kind of the FCZ, the ZZ, which we talked about before. This is something which comes later, but it's important that the electrode is, so the cap and the electrodes are on the place we want. So the one thing that we can go about is the center, so the vertex. So we need to measure to make sure that the central electrode is right over the top of the head. In this case, the central electrode is B16, and that's arbitrary. That's B16, but it's ZZ. And the way to find out if it's in the middle of the head, is to measure from the So you take a measurement from the nasion, which is this kind of like just point just above your nose, and this is difficult to see. You measure from the nasion, and back here is the inion, and the inion is this kind of bony little lump you have at the back of your head. Some people, if you have a feel yourself, some people have quite a prominent one, and some heads is quite harder to feel, but it's basically from the nasion to the inion. And what you want is you just take half of the nasion to the inion. So I have 36 here, which is about 18, and then you basically adjust the hat. Okay, a bit back and forth, and you can also measure from the top of the ear to the other top of the ear, so it's kind of right in the middle. Right. Once we're happy that the hat, or the cap rather, is in a good position. The next thing to do, and these vary a little bit depending on what kind of system you have, but in this case we need to put some gel in, and gel is, I don't know which one to hold in. It feels like I'm doing a cooking show. We just have some conductive gel, and this is gel which is quite easily to wash out of the hair with some hot water. It just basically makes a good connection between the scalp and the actual electrode. And in this case, you can see the little holes. You want to put a little bit of gel in each of these holes here. And it's always difficult to know exactly how much to put in. What you don't want to do is to put too much gel in. Because what happens if you put too much gel in here, and then I also put too much gel into this electrode here, a neighbouring electrode, what you get then is something called bridging. If underneath the gel goes from one and it seeps through and goes to the other electrode, then essentially this becomes one big electrode, and we can't differentiate then. And as we talked about before, that the spatial resolution of EEG isn't great, so we want to make sure that we make sure that we can do as much as possible to not make it any worse. So in terms of how much gel you put in, which is also the question you get when you train someone up in the lab, it's basically a very half a pea size. So something like that. I don't know if you can see very well. Okay. And what you normally do is to practice this. So in terms of putting gel in, so this gel will go in the hole. And this is just a syringe. It's got like a plastic nozzle, so it doesn't actually hurt the participant when you put the gel in. You kind of tend to err on the side of too little gel rather than too much gel, because it's a lot easier to put a bit more in compared to taking gel out, because it can get quite messy. Okay, right. So imagine that Mario has got gel in all of these little holes here. The next thing to do is then to just basically attach the electrodes. And let's see if I can show you some electrodes. Okay. For this particular system, here we go. I hope you can see. So these are the electrodes. And you see there's a little pin, you basically just put them in. Now, what's quite interesting is that these electrodes essentially have a little bit of, we call these active electrodes. They've got kind of a bit of amplification here, right at the start of the electrode. So they're active, and that means that there's in practice, this means that we don't need a Faraday cage as we used to do before, because there's very little. So a bit of amplification is done. Right at the top of the electrode, there's a little circuit in here, and that means there's very little interference of other stuff. Other noise can kind of get in the way of the signal from the tiny bit where it picks it up here, and to where it kind of there's a bit of processing of the data. And I think we'll talk a bit more about this in a lecture as well. But these are active electrodes, and because it's got a bit of a circuit board in there, essentially. I can also show you just here. This is one of these. This is an old school passive electrode, and essentially what this is just a gold-plated metal ring. There's nothing more to it, and you'd put some gel in, put this on the head, but there's no kind of amplification going on here. It all goes through wire, and this wire acts as a large antennae and picks up all the electrical noise everywhere else, and that's why you would need a Faraday cage.
I'm certainly old enough to remember using passive electrodes in my PhD research, as well as having a lot more noise in your recording. You have to spend a lot more time abrading the surface of the scalp to make as good a connection as possible between the passive electrode and the surface of the skin. It was much harder because of just that small amount of amplification that's done by the active electrode saves you a lot of hassle and gives you a much better recording than we did with passive electrodes in the past.
Yeah, and unfortunately, I'm also old enough to remember these. I used to use them a lot, and it was also sometimes quite painful for the participant, because you had to basically get rid of some dead skin cells on the scalp in order to get a good connection.
I've made a few participants bleed in the
That's probably stuff you should keep to yourself, John. Okay, right, we're back to, so we put electrode gel into all of these little holes, and now the next thing would be to just match up. All of these got a little number on it, so I can find, just be careful not to break, they're quite fragile. You'd go and find, so you have B4, which is B4 here. You basically just plug them in, okay? B2, it takes a little while. It's usually quite handy if there's two people doing this at the same time. B3 goes there.
So again, not to be confused by the jargon here. Although we've told you about the universal 1020 naming system, that was envisaged some time ago when the number of electrodes were really no higher than 32. And since the number of electrodes have gotten so much higher, and we're using 128 or sometimes even 256 electrodes on the surface of the scalp, the 1020 system just wasn't detailed enough to be able to put so many electrodes in the scalp. And so we've used other terminology, but by and large in papers, so that we can communicate between laboratories and keep a level of consistency, the 1020 system is still used to describe where an electrode is.
Okay, so this takes usually about 10 minutes or so. So you put all the electrodes in here. These are these are 32 essentially red ones and B, and then you'll have another set of electrodes which will be the A side. So in this cap we have 64 electrodes. All of those are in. Now what we're quite often interested, depending on your research, but I've done a lot of research when it comes to attention, so spatial attention, and that is when you see participants covertly attending to the left or to the right, for example. What's then interesting, if you want to look at covert attention, is to think about eye movements. And basically, the eye movements are very large, and large in terms of they will cause a large deviation of your data, and you can pick them up very easily. So to measure the eye movements, we can't use these kind of like pinhole electrodes. So what I've got here is, there you go. These are what's called flat electrodes, and they're just extra ones, and you put a tiny bit of gel in here. You put a bit of a little sticker tape on there. So there we go. Okay, bit of gel on there, and then put a sticker tape here, and then you put this on the outer. You'll see again, this is jargon. We said the outer canty of the left and right eye. Just means you put it on the side of the eye of little Mario here. Now it's maybe easy to show myself, but don't put it too close. The point is, it doesn't measure the kind of muscle movements of the eye in that sense. The front and the back of the eye are differently charged. One's positive and one's negative. So when you move your eyes slightly, left to right, horizontally, then these electrodes pick up that difference in positive and negative voltage. So that's what these extra electrodes pick up. These extra electrodes, they can be used for sometimes you call VEOG, so that's virtual electrooculogram, and that's just good for picking up blinks, if blinks are really important. I've also done some research where you can actually stick it on kind of close to your heart, and then you can get a heartbeat evoked. You get your heartbeat, and then you can kind of factor that in. A lot of interoceptive awareness research does that. Okay, here we are. We've done all the electrodes, and what we do then is I'm going to move Alfie out of the way slightly. He's still in. There we go. And now the participant would go into the EEG testing booth. And what we do then is we just plug them into the amplifier. And the amplifier here is nearly always it's going to be a battery operated one. And I think for two reasons that is. So having a battery. So this is a battery. That's an amplifier. Always remember to charge the battery. You have two reasons. One is having a battery is good because you don't want loads of extra electrical equipment in your in where you're doing the recording, because electrical equipment, they emit this electrical noise, as we call it. So battery operated stuff is better. The second thing is, it's never a good idea to have something connected to the mains, which is then also connected to your head. Okay, so I mean, of course, there's no electricity going from here into the electrode. It's only going from the other way. But there's definitely a bit of a safety measure to make sure that it's not connected to the mains in case something should go wrong. In this case, what you do is you just basically connect the electrodes, and this one goes in B, I can see here. And then you can see this amplifier. You connect the A electrodes, which will be the other side of the head, but you can have up to, well, you can have 8 sets of electrodes going in, so you can have loads of electrodes if you need to. But we tend to say, I mean, 64 and above is what is commonly used today. Above that, it's not necessarily that more is better. It just takes time, as you can see, to prepare each electrode. So putting 256 electrodes on someone's head, doing it this way, you know, you're looking at 45 minutes an hour at least if there's 2 people. And by that time, participants are usually quite tired before they've even started the experiment.
Those specialized, that kind of, that high number of electrodes are usually used in one of 2 circumstances. One where there's a very specific question that can only be answered by using a high number of electrodes. And that's usually if you're making an attempt at localization. A high number of electrodes gives you a slightly better spatial resolution, although you're still limited by the fact that you're using EEG. And the other reason I've seen a high number of electrodes used is in different cat types sometimes come with the electrodes already connected, and then it's usually you can't select how many electrodes you want to put on their head, but you're stuck with whatever comes with the system.
Okay, and I think that's nearly it. So all you do is you plug your extra electrodes in. So this is your HE or G electrode, and you'd have 2 of these, one on the left and one on the right eye. And then you would also put a connection from here into a fiber optic cable, which goes from here to the computer, which is in the lab. And this is how kind of it connects the circuit from the stimulation machine to the EEG recording machine, and it goes via this amplifier, and there's a connection here. You put it on, and then on the screen you should then see your lovely EEG recording. Yeah. Okay, so just to kind of finish off, we have the participant is now sat down in front of the, in the booth, and one thing to say is at this point, what we tend to do, all the electrodes are in, we hook them up and we have a look at the actual live recording, and quite often then you'll see, and you need to double check at this point, that there is a good connection. So each of these electrodes are giving you a good signal, because it's really valuable to get as good signal as possible here. And what tends to happen is in practice that you'll hook someone in, and then you look at the signal, and there'll be a handful of electrodes, which are actually quite noisy. And you'll see that on the screen where the signal's everywhere. And what you tend to do, you might then just wiggle electrodes around a bit. You might take one of them out, this specific one, have a look in and say, oh, I forgot to actually put gel into this little hole. You put a bit more gel in. There you go. Put it back in. And quite often the electrodes at the back of the head, so the occipital ones, there's quite a thick scalp back here, and there's also a lot of hair usually, especially for people with long hair. There's quite a lot of hair there, so in particular kind of wiggle and move the hair about. And you do this, it usually takes about 5 minutes. When you're happy with the signal and you it's basically a final bit of adjustment. That's it, and then you're kind of ready to do the recording. And now once the participant has done the task you're interested in doing, whether it's a memory task, attention task, and they're done. They're probably quite tired at this point. They come out of the booth, and basically you just take the cap off. They will be left with a bit of this gel in the hair, so we do have facilities here that they can wash their hair out, and we provide a towel and, importantly, a hairdryer. And that is pretty much it in terms of like the preparing participant for EEG and then following and taking the cap off. You then wash the cap and the electrodes in some warm water and hang it to dry and ready for your next one.
Great. We're very used to doing this, and much of it is second nature to us. So if anything wasn't clear, if you didn't understand anything, if you would like something explained in more detail, either post something to a forum or come to the seminars and ask us about it. Yeah, I hope you enjoyed it.